Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 3rd, 2025, just a couple of days ago. It introduces a new way to render those tiny sparkling glints on surfaces in real time, adding only about half a millisecond of render time on a high-end GPU. The paper is titled, Real-Time Image-Based Lighting of Glints 2507.02674v1, and as we'll see, the visual results are almost indistinguishable from the ground truth. Essentially, it solves the tricky problem of making glittery and metallic surfaces look realistic under complex, changing lighting. And right away, the first figure gives us a fantastic look at what this technique can do. We see three very different examples: a woman in a glittering dress, a car with that sparkly metallic paint, and some very detailed Christmas ornaments. What's happening here is a technique called image-based lighting, or IBL. That's where you use a full picture of the surrounding world to light a scene, which creates incredibly realistic reflections. The results here on these varied surfaces look amazing, showing just how well the approximation works in real time. So, to understand how they achieve those results, this next figure breaks down the core concepts. We see three spheres representing different aspects of how a rough surface reflects light. First is the bidirectional reflectance distribution function, or BRDF, which is basically a model describing how a surface reflects light. Next is the normal distribution function, or NDF, which maps the orientation of all the tiny, microscopic facets. Finally, we see the image-based lighting kernel. This kernel is their clever approximation, which simplifies the complex bidirectional reflectance distribution function into a single filter to make the process fast. Building on that idea of an image-based lighting kernel, this next figure shows how they simplify the lighting itself for speed. The top row shows an environment map, which is the 360-degree picture used for the lighting. They take its logarithmic radiance, a way to measure a vast range of brightness, and simplify it into just a few levels. Here we see 8 and 4. The middle plot shows the distribution of all the brightness values, and the bottom chart shows how each pixel's light is smoothly distributed between two levels, which is key to the natural look. So, moving to the results, this is where we see just how well that simplification works in practice. This figure shows a whole grid of spheres, comparing their method using 4 and 8 light levels against a reference rendering, which is the perfectly accurate or ground truth image. They test this across different surface roughness levels and also different microfacet densities. A microfacet density is just how many of those tiny glittery flakes are packed onto the surface. And as you can see, the results, especially with 8 levels, are almost indistinguishable from the reference, which is really impressive. Now, it's one thing to compare against a perfect reference, but how does this new technique stack up against previous work? This next figure answers that directly. The top row shows the new method with 4 and 8 light levels next to the reference. The bottom row shows a previous method, which required a manually adjusted parameter called gamma. You can see that the new approach, because it actually analyzes the lighting environment, produces glints that look much more natural and match the reference far more closely. This table then details the performance costs, really how fast this all runs. We're looking at render times in milliseconds on a couple of high-end graphics cards. They compare their new method, using 4 and 8 light levels, against a standard smooth surface and that previous method we just saw. The key takeaway is the efficiency. On an RTX 4090, using 4 light levels only adds about a millisecond compared to a smooth surface under static image-based lighting. That's a tiny cost for the huge visual improvement, showing the technique is practical for real-time applications. Alright, so to wrap up, we've seen a really practical and clever method for rendering glints, those tiny sparkles you see on glittery or metallic surfaces. The authors manage this by taking complex image-based lighting, which again is using a full 360-degree image to light a scene and simplifying it into just a few key brightness levels. The result is a technique that's both incredibly fast and visually convincing, making it a big step forward for real-time graphics. That's our roundup for this week. I'm Alex. Thanks for listening.